Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today will be the settings of the statics analysis. I've opened one of the examples that we've seen a couple of times in previous lessons, but this is a basic static analysis, and the purpose of these lessons it is to explain a little further all the options that are inside this solve command, which opens this dialog box. Okay. So we have this first tab called General, and in here we can define the properties of the current study. These are basic fields, so we can set a couple of parameters. We can do it here, or if we go to the study, we can change them also under here. So if we click, for example, in the properties of this study, we can change the values and the parameters, and those will be affected also. Let us change this, edit, and we can change a couple of things, the description, the parameters of these. We can go and say CAD soft or whatever, okay, and do it. And when we go to this same window, we have this information changed. So we can change also the type, we can insert comments, whatever. It's basic stuff. And we can have this shown with this option on, display the dialog box before solving, which I think it is interesting. Then moving to the solve, we have a couple of interesting parameters regarding these two groups, solving method first and finite element method also. So solving method, we have this automatic assignment, and in this we have the possibility to do everything in kind of automatic mode. Okay. Then we can have this direct method, and in here we have a system of equations solved by Gauss method. And there is a lot of more details about what this method does. These are mathematical formulas and description, which I think it's not so interesting, the complete detail of what is inside. But when we choose the direct method, we have a couple of settings, and basically the settings in this case have to do with the management of the memory that we may have available in the computer. So we can have this managed automatically, and the system will manage the quantity of RAM memory that is used in the calculation. We can have also, this is additional memory. We can have also the possibility to have additional memory, okay, or never use additional memory. This is important, especially because when we are dealing with very complex and very large studies, we can create a high number of equations that will create also very high quantity of megabytes or gigabytes in the case, and we may have the need to increase this memory. And we can have, for example, an external disk doing some additional memory to the system, which is interesting in my perspective in some cases. Besides that, we can have this on or not. The use angle-threaded solver, the single-threaded solver, which will control a little more the quantity of or the speed that the calculations are done. Then we have also this iterative method, which in fact deals again with the same stuff about the additional disk memory used and these preconditions. We have four modes. We have the combined mode, which is the fastest solution and uses the minimum number of iterations. But at the same time, it uses a lot of RAM memory to solve the study that we have in hands. Then we have another method that is called the incomplete expansion. This does not need so much memory, but the number of iterations is decreased, and it's not as effective as the first one, as the combined. Both of these two guys, the diagonal and the singular, provides minimum requirements to the additional RAM memory, but require a large number of iterations to obtain a solution, and therefore they are rarely used in studies that have practical interest. So this will take longer time to work, so I would not recommend to use them. Also in these interactive studies, we have a couple of parameters to be used. One, it is this accuracy, and this will increase the accuracy of the solution. A smaller value, as you might understand, will create a great number of steps and more time. And we have also this maximum number of iterations that if we reach the number of iterations that are defined here, the system will stop, even that we don't reach a desired solution. Okay, so these are things to work with and to manage with some experience, also to work with these guys. We have also an accuracy regarding contact definition, which we can increase or not. So it's another possibility. And still under this topic, we have the stabilized system, which also has some settings. And this stabilized system allows us to carry out analysis of systems that are non-fixed in space, but they are equilibrated by forces. So we need to have certain conditions, and usually in this type of calculations, we use a model which is not constrained in space, or saying this in other words, that has the capability to move in space as a rigid body. But in these conditions, the finite element analysis becomes impossible, because the body or the system will fly in space. So with this option, we can stabilize the system, allowing us to overcome this limitation of the system being equilibrated in space by forces. This principle, it is to apply a stiffness, which we can have in here, which is sufficiently small compared with the stiffness of the model, and does not influence the distribution of the deformation and the stresses and so on. So, and you can manage this to reach a compromise that is okay for your study. You can read a little more about it in our theoretical side. So it's the first approach to this thing. In terms of the finite element method, we have two methods, the quadratic tetra, and if you choose the other one, the linear tetrahedron, you see that this quadratic method, it is basically used for get numerical calculation, and this one, it is for estimations more. So this is not so recommended if you want to get precise values and numbers in your study. So use always the quadratic tetra because it is better for your results. Then we will jump now, we will go to the thermal effects. And these thermal effects, it is the possibility to include thermal loads in the calculations. Okay, first one, we can have these the consideration to use thermoelasticity, which in fact it is a possibility to include the calculation loads that build up in a structure due to the linear expansion forces under the condition of it that is applied to a body or to a system. We can also consider the dependency of the physical properties from the temperature, okay? And we can give this non-stress state, which is the temperature that we consider that we have zero deformation, and we can define that temperature, and we can define which are the units also. Then we have these fields here, which are the methods of specifying the thermal loads. We can say that we have uniform temperature and that is applied to all the bodies, and again values and units, or we can use a preset temperature that is given outside in this temperature as a load also in the study. And then we can have also these, we can use these thermal study results, which we don't have in this particular case, so that does not make sense to see them now in this study, but it's also a possibility. We have also another tab here that is called nonlinear, and nonlinear has also a couple of important parameters. The first one, it is the possibility to use a special mode that we called as huge large displacement formulation. When we have very big displacements, the general conditions study do not apply, so it is important to have this special mode. Then we have these number of load steps, which we can insert a value, and this option allows the user to set the number of steps during which the load will be changing from 0 to a specified value. Theoretically speaking, all solutions can be found within one step for the total value of the acting load. However, this arises the possibility of a non-uniqueness of solution, and moreover, the found solution may not have physical meaning. So it is important to specify the load incrementally and to obtain a non-linear solution for each increment. This is what we can get for this. We can have also, or we can enable the possibility to update the load direction with the deflection. And we can, this allows the user to account for change in the load vector while applying the loading according to the deformed geometry of the model. And we can choose one of the methods, the Newton-Raphson or the Newton-Raphson modified method. This is a little theoretical, you can search a little more about which both of these methods, what each one of them do. So let us leave now the standard one, the Newton-Raphson. Then we have also, and again, the relative accuracy, which it is the possibility to increase or not the accuracy and influencing also the time to reach a result, and the number of iterations that again reaches the larger a value larger than the specified one. And if we reach this total number of iterations, the calculation will stop. So it's kind of it's not a filter, but it's a limit where we will stop working with the study, so that does not create a very big calculation and very time consuming. Finally, in terms of the results, we've seen also a couple of times this dialog box, these options. So we can enable also this option, save the solving in a file, and if we activate this, the analysis results are saved together with the file, in the file together with the model, sorry. With this we can analyze results later, and we have them available. We save some time to recalculate everything. As you might understand, this will increase the size of the file, and this will be bigger if we have more results in the study. So these are groups of things, and these are they depend on the type of calculation that we are doing, but okay, we can choose from all of these things which are the ones that we want to study and to do. I think it's already more or less clear about this possibility. So you can check a little more either on the help part of the manual, or also in our theoretical course. But as a basic description for what we can get in this solve window, I think it's a little more, it will help you clear a little more the options you have in mind. So you can make a couple of tests also with all these options, with the accuracies and the different methods, to see the kind of results, the speed, and the accuracy of the solution. So it will be also interesting for your side to explore a little more these options. Any help, any additional clarification about all of these topics, let us know, and we will give you all the support.